Assalamualaikum and hi. So today in this video we are going to look at subtopic 5.5 from chapter 5 mutual inductance. Okay, there are two learning objectives in this subtopic. The first one is to define the mutual inductance and the second one is to use mutual inductance between two coaxial solenoid. Okay, what is meant by mutual induction? Okay, mutual induction is defined as the EMF induced in a circuit by changing current in another nearby circuit. Okay, so mutual inductance is when you are going to induce EMF in one circuit due to the changes in another circuit. Okay, kalau before this we have looked at self-inductance where you have power supply and then you have variable resistance and then you're going to have your solenoid. Okay, kita akan induce EMF dalam diri dia sendiri. You're going to induce the EMF in the circuit itself when you vary the resistance. So bila kita vary the resistance, dia akan lead to the change in the current dan change in the current ini menyebabkan change in the flux and leads to EMF being induced di dalam diri dia sendiri disebabkan oleh perubahan dalam diri dia sendiri. However, mutual inductance pula, you are going to induce EMF dalam satu circuit disebabkan perubahan oleh another circuit. So, akan ada dua circuit dekat sini. Okay, for an example, you're going to have circuit 1 and also circuit 2 where in circuit 1 kita ada connect dengan power supply, kita ada rintangan and then you have your solenoid lah dekat sini. This is your solenoid. And in your circuit kedua ini, kita tak ada power supply. You do not have anything. You only connect it to the galvanometer. Okay, kita hanya connect dia dengan galvanometer to detect whether ataupun to detect the presence of the EMF dekat dalam sini. Okay, boleh jadi juga kita ada coil. Okay, kita ada circular coil where the circular coil in one circuit is connected to the power supply and then kita ada power supply. Another circuit, you do not have power supply, you only have galvanometer where galvanometer is going to read the presence of EMF. Okay, so contoh dekat sini adalah when you close this circuit, bila kita tutup, arus akan mula lalu. You're going to have current flow from the positive terminal here. Current akan pergi naik atas di belakang solenoid dan dia akan turun di hadapan solenoid. It's going to come down in this direction. Turun, turun dan turun di sini and then the current is going to go here. Okay, so apa yang akan jadi adalah bila current flow, you are going to experience magnetic field. Okay, guna right hand grip rule, deduce the direction of magnetic field. According to here, bila kita ada current one flow in this circuit, kita akan ada magnetic field produced to the right dekat sini. Okay, so at this particular point, kawan dekat sini, you do not have any current flow sebab you do not have power supply. Okay, so let's say sekarang apa kita buat adalah kita switch off kita punya switch ini. So kita tutup, maksudnya kita buka baliklah kita punya circuit. When you open the circuit here, arus akan mula berhenti untuk flow because you do not have a complete circuit. So the current will start to decrease. Bila current start to decrease, flux akan decrease because for solenoid B is equals to mu naught Ni over L, B directly proportional to I. So I decrease, B decrease, flux pula sama dengan BA cos theta. So bila B decrease, flux akan berkurang. So when flux that you had initially is going to decrease now, kamu punya circuit kedua ini akan merasa pengurangan itu. Okay, dia akan experience B yang sama, so dia akan experience B, flux kamu berkurang. So initially you had B and then that B is going to decrease sekarang. So when you experience that decrease, you are trying to not make sure the changes occur. Kita tak nak perubahan itu berlaku. Okay, so bila kita tak nak perubahan itu berlaku, what is going to happen adalah you have your B in this direction, betul tak? B external kamu ke kiri. So along the solenoid kita akan experience B external, sorry bukan kiri kanan B external ke kanan. So sekarang untuk oppose the changes dekat sini, this solenoid here is going to induce the magnetic field which is in the same direction dengan B external. Sebab bila flux decrease, kita punya B induced same direction dengan B external. So kita akan produce B induced yang ke kanan juga. So this is the direction of your B induced. Once you have deduced the B induced dekat sini, kita boleh ada current being induced using the right hand grip rule. So bila ada current yang akan flow, so the current is going to flow such that dia akan turun ke bawah di hadapan coil ini. When you grip your fingers, you're going to get your current is going down. So current akan turun dekat sini lah. So current naik dekat sini, naik dari belakang, turun dekat depan, and then datang balik, turun dekat sini. This galvanometer now is going to deflect to show that there is presence of current here, maka EMF has been induced. Okay, so EMF yang kita induce dekat circuit kedua comes from the changes that occurred in the circuit 1. Okay, so this is what known as mutual induction, iaitu to produce EMF in another circuit disebabkan oleh perubahan dalam one circuit. Okay, perubahan dekat circuit satu, tapi EMF yang kita induce adalah dekat circuit yang kedua ini. The same thing akan berlaku untuk you're using the coil lah. Konsep dia masih sama. So according to the Faraday's law, EMF is induced in the loop 2 to oppose the changes. The induced current in this loop that causes by the change in the current in the neighboring loop is what we call as mutual induction. Iaitu changes of currents in the neighboring loop leads to the current being induced in one loop, maka EMF is induced also in that particular loop. So for an example, refer to the following diagram. So what we have here is, we have one coil, coil 1, which is connected to the battery, and we have coil 2, which does not have any power supply, but we connect it to a galvanometer to read the presence of EMF being induced. Okay, so two coil play side by side coaxially. Coil 1 is connected to the source of EMF battery. Coil 2 is connected to a galvanometer. When the current start to flow in coil 1, so kita akan ada current daripada positive here. It's going to go here. Okay, it goes up, I1. Okay. Magnetic flux will begin to build up inside the coil. So kita akan mula ada magnetic flux dekat sini, because when you have current, you are going to produce B, akan ada B, and then kita akan ada magnetic flux. Since coil 2 is placed near to coil 1, thus this magnetic flux will also passes through coil 2. Okay, sebab dia berada dekat sebelah, kita akan tempias lah. So whatever magnetic field yang kita create dekat point sini using your right hand grip rule, sebab kita tahu dalam chapter 4, when you have I, you can produce B. So kita akan produce B in this direction. So this is your B external. B external ini akan tempias sampailah dia kena coil kedua kamu. So your coil kedua pun akan ada flux. If the current in coil 1 changes with time, so if you change the current, magnetic flux through coil 2 will change with time too. So bila kita ubah current dekat sini, apa yang akan jadi adalah dia akan experience change in the magnetic field dia ini. So magnetic field dia akan berubah. So bila berubah, flux dalam diri dia, iaitu flux 1 is going to change juga. Okay, so when the flux 1 changes, it is going to cause your coil to experience that changes. Coil 2 ini, dia dah selesa dengan whatever you gave initially. Apa yang kamu bagi awal-awal tu dia dah selesa. So bila tiba-tiba berubah, dia tak nak perubahan ini. Okay, so according to the Faraday's law, coil 2 will experience an induced EMF. So dia akan induce EMF dia sendiri sebab dia nak oppose the changes dekat sini. The production of induced EMF in coil 2 caused by the changing in the current in the neighboring coil, coil 1, known as mutual induction. So konsep to produce this EMF masih sama dengan apa yang kita belajar dalam 5.2 itu. It's just that changes in one coil leads to production of EMF in another coil. So EMF is induced in coil 1 by changing the current in EMF is induced in coil 2 by changing the current in coil 1. So in mutual induction, the EMF induced in one coil is proportional to the rate at which current in another coil is changing. So lagi sekali in mutual induction, EMF induced in one coil. So contoh kita refer kepada diagram ini, EMF induced in coil kedua is proportional to the rate at which the current in another coil is changing. So current berubah dekat coil 1. So dia directly proportional to the rate of change of current in coil 1. If we assume that the current in coil 1 changes at the rate of di over dt, okay, di over dt, the magnetic flux will change by d flux 1 over dt, and this changes is experienced by coil 2. Okay, bila current berubah, kita tahu current menyebabkan B berubah. Bila B berubah, flux akan berubah juga. So kita akan ada d flux over dt. Okay, so whatever changes yang berlaku ini akan di-experience oleh coil kedua juga. So the induced EMF in coil 2 is given as, induced EMF is directly proportional to negative di over dt. Negative ini adalah referring to the Lenz's law itu. So this proportionality can be referred as induced EMF in coil 2 is equals to negative mutual inductance M12 di1 over dt. Okay, mutual inductance dekat sini kita guna subscript 12 adalah disebabkan oleh changes in coil 1 leads to the production in coil 2. Okay, so EMF 2 M12 di1 over dt. So M12 is mutual inductance of coil 2 with respect to coil 1. Okay, inductance of coil 2 with respect to coil 1. Negative sign is an expression of the Lenz's law. Okay, negative ini adalah Lenz's law, indicating that the induced current will oppose the change in current 1. So current yang kita akan induce dekat coil kedua akan cuba oppose perubahan dalam current in coil 1. So according to the Faraday's law, EMF induced in second coil is, okay, so this is the equation lah, kita tulis balik dekat sini. According to the Faraday's law pula, kita relate dengan EMF 2 is equals to negative and d flux over dt. Ini Faraday cakap, betul tak? So EMF induced in coil 2, flux changes in coil 2 juga. Sebab bila flux berubah dekat coil 1, okay, apa saja perubahan dekat coil 1 dirasai oleh coil kedua. Sebab apa? I repeat myself. Initially kita ada B external. So B external ini akan tempias dekat kita punya coil kedua juga. So dia akan produce flux dekat diri dia sendiri. Okay, and then when the B changes, B kita berubah sebab kita ubah I, flux dekat sini akan berubah, leads to the change in the flux dekat coil kedua juga. So perubahan flux yang dirasai oleh coil 1 dirasai oleh coil kedua. Okay, change in the flux in coil 1 is equals to change in flux in the coil 2. So EMF yang kita induce dekat coil kedua sebenarnya directly proportional to the change in the flux in the coil kedua juga. Okay, since both adalah equation for EMF induced in second coil, satu kita relate dengan equation of mutual inductance, satu lagi kita relate dengan Faraday's law. So when you combine these two equation, kita akan equate negative M12 di1 over dt sama dengan negative N2 d flux 2 over dt. You cancel the N, kita akan dapat M12, kita integrate di over dt, kita akan dapat I 1, and then kita N2, kita integrate juga ini di flux over dt, kita akan dapat flux kedua. So your mutual inductance is actually N2 flux 2 over current 1. So the changes in the current 1 leads to the flux change in coil yang kedua ini. So you have to remember lah. So dia sentiasa berbeza. Current dalam 1, flux dekat 2. So dia tidak sama Okay, for mutual inductance kita akan ada N2 flux 2 over I1. Kalau kita compare dengan self-inductance, perubahan dalam diri sendiri menyebabkan you induce EMF in yourself. So you have equations such as L, self-inductance, is equals to N flux over I. So kalau kamu tengok equation dia sama sahaja, it's just that dekat sini it is necessary to write the subscript to indicate that you are producing the EMF in the second coil. So the flux from the second coil, however, due to the current in the first coil tadi. Okay, so begitu juga if you want to know this process vice versa, so the changes in here akan menyebabkan changes in here juga. Okay, boleh jadi daripada coil kedua kita reverse balik kepada coil yang pertama. So you can rewrite this equation such that mutual inductance of coil 1 with respect to coil 2 pula akan sama dengan N1 flux 1 over I kedua pula. So this means that you are trying to induce the EMF in the coil kedua, maka in the coil 1 you are having the flux in coil 1, maka due to the current in coil kedua dekat sini. Okay, so for a given pair of coil, the value of mutual inductance is the same. So basically nilai mereka akan sama and does not depends on which coil carries the current and which coil experience the induction. So it doesn't matter sebab dia punya proses adalah vice versa. Okay, so the M12 sama saja dengan M21. So it doesn't matter siapa yang carry current, siapa yang akan experience the induction. They still produce the same mutual inductance. Sebab tu nama dia adalah mutual induction. Okay, dia adalah mutual induction. So you're going to experience them mutually. And they use the unit Henry juga. Okay, unit untuk mutual inductance adalah Henry, sama macam self inductance which is also Henry. Okay, another important note dekat sini, EMF induced in coil 1 due to current change in coil 2. Okay, kita akan dapat EMF dekat coil 1 if current kita berubah dekat coil kedua, and then the same thing juga EMF dekat coil 2 disebabkan current berubah dekat coil 1. Dia kena vice